Okay, so we have to evaluate this integral. Now, in order to accomplish this, we have to, well, first of all, it's a good idea to try to simplify the expression in the square root sign, and then see where we could go from there. So basically, we just go dx square root of, let's take out the -1 and rearrange the terms as follows. So it's x squared minus 2x minus 3. And now, it's a good idea to actually, if we're square root signs, it's a good idea to try to complete the square, see where that goes. So if I try to complete a square here, so I have to divide this by 2, just to demonstrate. So minus, if I divide by 2, I simply get x minus 1, you square that. And then I still have my -3, but of course I have to subtract the square of 1. So I get the same expression that I did initially. And so it's essentially just the square root of minus x minus 1 squared minus 4 quantity multiplied by -1. So essentially we get the following: minus x minus 1 squared minus 4, right? Minus 4, right? Because minus 3 minus 1 is minus 4. And now, look at this expression. Let's try to distribute the -1 once more. So this now is going to be positive 4 minus x minus 1 squared. And now, we know that this has a particular form. And in order for you to see this very clearly, first I'll have to use u-substitution. Basically, I'm going to let u equal to x minus 1, which is this expression here, or that term there. And then, excuse me, that's u. So du is basically equal to dx. And if I substitute everything back in, I'm running out of space. So I get the following. So 4 minus u squared, right? And this has a typical form. Basically, the antiderivative of this should be the arc sine of u over 2. Basically, it's one of those things that you have to memorize. You can certainly go through it step by step. However, to make the computation faster, it's better to memorize this. So let me just write it down for you generally. So basically, if I differentiate the arc sine, so dx of sine minus 1 of x over a squared, right? I'm basically going to get a minus x squared, right? And applying this basic result that we probably would have obtained from calculus 1, we can simply apply it here. So it should be arc sine of basically u over 2. So we're just going to write this neatly here. So it should be sine minus 1 arc sine of u over 2. And also remember, this is an indefinite integral, therefore we should have a constant of integration at the end. However, we're not done yet. We have to substitute back for u, right? Because we're using u substitution, we have to substitute back for u. We said u was what? We said u was basically this, x minus 1. So basically we substitute back, so x minus 1 over 2 plus c. And that's basically your final answer.